Welcome back to Learn Safest. In previous video, we have seen how to import and save file, how to do geometry cleanup and featuring, and how to create mixer page. Now today we will see how to do 2D meshing. So before deciding the meshing, or before deciding the selection of elements, so you need to see what are the things to carry out to do the to check which type of element is selected to be. The element type selection is depends on mainly welcome back to Learn Safest. In previous videos, we have seen how to import and save file, geometry cleanup, 2D mesh, 2D meshing. We have extracted the mixed surface. Now today we will do meshing. So same thing as I said in the previous video. We have to open the Hypermesh window and directly go to the open. Here the plane 2 is the mid surface. Just open it. Yeah, this is the mid surface extracted from the sheet metal component. So before this, I want to say the type of we will discuss some things about the element, where the types of elements are, as we know, 1D, 2D, 3D, and others. And we have the selection procedure like if the component have length of this one size is more compared to others, like breadth and thickness is less, or if the length of the component is more comparatively its thickness and height, we go for 1D. If the length of the two sides are comparatively compared to one, like here we have 2 mm thickness and the width is 40, length is 50. So we can go for 2D for this kind of component. And if the length, width and thickness are similar in size, we go for 3D. So which is suitable for the 2D elements, we go for it. And then the element type selection is completely depends on the geometry, size and shape, type of analysis, and the type allocated for the project. So here we have two components. This is the mid surface, make it current, it is already there. So size of the element, as I said, size of the element depends on the type of analysis. If we are doing nonlinear analysis, we make the use of time step. If we have a formula, we will see in nonlinear analysis how to decide. But in a structural analysis, it generally depends on the geometry, size and shape, and maintain odd element over a tri element. Always avoid tri elements because it will give more stiffness to the element. So we will discuss in the next video, where I will explain the theory of the tri elements, why it will give more stiffness rather compared to four. So we will decide for this one. We have a 45 element, 45 mm and 55 mm. So 5 mm is the average element we will take, and we will maintain 5 mm as the element size. For that, we need to have a shortcut called F12. We have an F12 or mesh option is there. In F12, shortcut F12, we have this panel area where we have surfaces and the elements. So we have the graphical area surface, so we keep the surface. Here we have size and bias, batch mates and Q optimize, edge deviation, surface deviation is equal to mesh. So we'll explain one by one. Now we'll go with the size and bias. Most of the 2D meshes are always go with the size and bias. So you can set up the size of element size. Usually we have it at 5 mm, and you can choose the mixed or quad, mixed in the terms of quad and trias, quads or hard trias, quad only. So I will make sure it is quad only. Now next, this is the element surface, which it will go to the surface, and first order and second order is there, option is there. We keep in the first order. So In next video, I will try to explain what is first order and second order and what are the type of elements in depth. So now we'll keep the first order, and next we go for meshing. So here mappable and skew, you click on it. Aspect ratio you keep as it is, auto you keep, or if you won't have the calculation of it, and you can assign the values here. So just keep the auto. We have the surfaces, and heat the surface. Before starting this one, make sure that your surface has split in a proper way, so that your element should get a proper flow of the element. So next we'll go with it using F11 as shortcut. We have here F11. Similarly, if you're not getting shortcuts, geometry, here the surface option are there. Here in this term only you will get quick edit tools. Here the F11 shortcut is quick edit tool. So this is node to line. If you have nodes, you can split it. If node and line, you can split it. Node to node, you can split it. You can create the washer split. So I will use it. How to do that? So I will explain. You can toggle the edge. You can delete the surface. And you can fill the surface. Suppose if it open, you can fill with this alpha. And you can toggle means if you have a line, you can hide it. And split and then split the surface. So next for this one, if you have the opening area here, so let's make sure. So before that, you start in the geometry shape where critical area. If you're not finding the critical area properly, go with the open slots. First, make sure that the hole size. Split the hole, make it to 2 washer split or 1 washer split is fine. So first, before that, you will check the size of the radius of it. So it is dia 15, its perimeter is showing. So just check the F4. So it has 5 mm is the dia, 5 dia. So for the washer split, we have 2 into D, that is 10. You can keep 1.5 D. Just check how it will show. Otherwise, 2 washer split you are maintaining, and for this also you can maintain. Otherwise, you can go with directly by splitting the shape. F11 same node, just create 2 besides this line, it will split. This line it will split. So by splitting this type of method, you can maintain the proper flow. Okay, so try to make. So the now splitting means this line is core coming with this radius. So we will maintain this radius, right? So we have to capture this. So I will split according to this. So we have the splitted area. Here also we will split. Making this type of splitting, you can control over the mesh area or a mesh flow. Just see how I will do this one. It's a very basic method to do the meshing. So we will go with it. So same thing I will split here also. Okay. Now go with the